Good morning, everybody. I'm Equation Hardy, Biomedical Engineering major.
I'm Kamora Carter, Biomedical Engineering major.
Bobby Raggis, Computer Engineering major.
I'm Marcus Daughter, Computer Engineering major.
Curtis Patrick, Computer Engineering major.
And with the Raytheon drone team, we were supposed to compete in the Raytheon 18-inch competition. However, our plane got delayed until the next day, so we missed the competition. But we're still gonna show the progress that we had and how we complete our project. So,
Can you go back to the first?
Yeah,
was
we're all
easy.
scribbling names. Sorry about that.
So, are they listed the way you're standing there?
No, sir.
That's,
this is Curtis
That's
Patrick.
Curtis.
this is Mark Adrian.
Okay.
I'm Kamora.
Marcus,
Bobby.
And Marcus.
I'm Marcus.
Marcus over there.
We also have one more team member, Jemiah King, but she is with us right now.
Bobby Ragus, okay, thank you, sir. That's a big team there.
Yeah.
How do you keep coordinated?
We meet just about every week.
Every day.
Two or 3 times a week.
You need shorter names.
Yeah, every day.
Thank you very much.
Yes, I finally got it. Sorry, that took so long.
No, it's fine.
Everybody ready? So, the main thing for our mission was that we're going to compete in the Raytheon vehicle competition. Basically, Raytheon gives out a grant, money to different schools for us to compete and do the different tasks that they have at the time. So, for us, and in similar terms, we had completed 3 different challenges with kind of more going into more detail about. And we had to create essentially 3 different vehicles. So we had 2 air drones, one which was powered by Raspberry Pi, which was autonomous, another one that was manually driven by Bobby Ragus, and we had an autonomous ground vehicle as well.
The Air Force has a blue list, and you can't fly anything over government property without being on that blue list. Now, the drone, I don't know what certification that drone, I'm a drone pilot, and I don't know what certification that you're gonna meet, or you'll fly it over Raytheon.
Okay, so basically Raytheon basically gave us like a certain tests we had to take, and they already had certificates for us for the fly in a certain zone, because we were gonna compete in the school, so they already had, they kind of already communicated with everything.
That was sent to us, and they told us like to have at least 2 people, or a requirement to at least have 2 people do the drone certification and send in the certificate that it gives you at the end. So we did have 2 people that got that done. Unfortunately, Jemiah was one of them. She's not with us, but Bobby was our other flyer.
There's different categories, AMA has appealed, it's near a dump site, and you get insurance flying there. And then if you fly near airspaces, there are big restrictions, Of course, Forest is a real tiny airport, not really regulated that much. But then you've got 2 categories on unmanned aircraft. You've got a recreational flight, and then you've got commercial flight. And so I don't know what categories that you're gonna be doing.
So
Let me jump in real quick. This was a competition that was supposed to take place at the University of Texas at Arlington. So it was on a football field. There was no airports or anything like that. So when they say Raytheon, is actually a Raytheon in in Texas, not as far as,
Oh, it's a McKinney.
yeah. So
Okay,
this is
gotcha.
all, recreation.
All right, great, thanks. That'd be nice to see that. When are that gonna be?
Oh, no, that was last Friday.
What was it?
It was last Friday.
Oh, last Friday.
But to
Daily
answer,
pictures?
to answer your question specifically, though, it will be considered under recreational because it wouldn't be anything like bringing it in.
Okay, thanks.
Okay, so our competition or our project consisted of 3 different challenges. We were able to get the first challenge done, and that was our main focus for pretty much the entirety of our project, because that's what we planned to do once we got down there. So for the first challenge, the ground vehicle has to land on top of, or the air vehicle, which would be the drone, has to land on top of the ground vehicle in a minimum of, I think, 7 minutes at 0.2 speed, and it has to land on top of the ground vehicle for at least 30 seconds. And then challenge 2 and challenge 3 are pretty similar. Challenge 2, there will be a Roku marker that has to find the QR code and send the code back to the ground, or the air vehicle, to be able to go and find the ground vehicle and land on top of it. And challenge 3 is pretty similar. It's basically the same thing, but there is an obstacle course in the way of the Roku marker sending that signal back to the ground vehicle for it to be able to land on top of it.
So right here is basically the 2D model of the challenge 1 of us moving taking off with the drone, and then once the drone take off, we trail the ground vehicle, and once we trail it, we land the ground air drone onto the ground vehicle for 30 seconds.
And for the first challenge, we did complete the ground vehicle. It's just moving in a straight line, if that makes more sense.
So by value proposition, we deliver optimized student-built autonomous drones that demonstrate, distribute autonomy, technical integration, and real-world performance. And by channels, we showcase our capabilities through live competition, demonstration, and technical documentation.
So this is our time lapse of everything we did throughout the whole both semesters. And this is live, but I say the main things midway through last semester. That's when Raytheon officially, like, I want to say, authorized us to actually compete in the competition, which we got the paperwork and everything. Towards the later part of the semester, that's when our sponsor, Dr. Belzer, started getting our different materials and everything together. And by the end of the fall semester, we had our ground vehicle built. Going into the spring semester, our main focus was getting the air drones. So we got 2 different drones because we had our big drone, which is like the one we made in the autonomous with the Raspberry Pi 5. That drone it took us longer because we had to work on a GPS unit. We had to work on actually putting it together, learning, figuring it out, because like I said, with a Ruko marker, which we learned through computer vision, we had to work on actually coding that and getting to understand how that actually works. So we had another drone, a smaller drone that was mainly driven by Bobby. That was more simple for us to put together, and we worked with that. And from there, we kind of translated that to the bigger drone to understand it more.
So this is our ground vehicle that we're working with. It's very simple. It's just a metal frame attached with 4 motors, battery, and the Arduino. We programmed the Arduino to go for a certain distance, at a certain speed. We changed it based on there's a lot of trial and error with it. We changed it various times. And it used a 12.6 volt battery, lithium ion battery that used to power it. I'm gonna say, we changed it several times, because we had it going from like 10 seconds, 20 seconds, going back like half speed, full speed. Right. This is a test trial. This was just like a little trial video we did trying to get the air drone to land on it, see if how many times we can get it. It was kind of generic. I wanted to like employ like a little button on it. I was gonna get that set up once we get down there, because I had to take it apart, but we never made it. So
So this is the air vehicle that we use. The key capabilities are autonomous takeoff from the ground vehicle. We have flight control via the onboard computer, which is the Raspberry Pi. We have a USB webcam connected to it for Aruka marker detection and precision landing on the ground vehicle. And we have the GPS unit that was attached to the Pixel controller. And the software components we use are Ardu Pilot, Mav Proxy, Drone Kit, OpenCV, and the Aruka library. And the hardware that we use were the lithium-ion battery, the flight controller, the RC receiver, Raspberry Pi, the GPS, USB camera, the motors, and the wireless communication module.
And we have right here is the video of the big drone, which has the Raspberry Pi and the webcam connected to it. And it's just basically, get flying off and going around for a little bit.
So this is just a little idea of the code sample for the ground vehicle. I was using Arduino IDE, which uses C and C++ language. It also comes, I used a header to manipulate it easier. It just has simple functions going forward, backward, and release, which is just like make it stop, but not stop. Make it stop gradually, not immediately. And we basically just had to make sure we get the speed right so that the tires will rotate at the right, just rotate the right speed. And we used like a, let's see, power modulation. So I only had to set like 255 as max speed.
So this is the code sample for the air vehicle. For autonomous flight, we use the Pixel for flight control. The offboard mode, we use MavLink using Mav Proxy and Python. And the mission was to take off, navigate, and detect the Aruka marker and land on the moving ground vehicle. We have controllers used for position, altitude, and smooth landing. And the safety features we have are the geofence, fail-safe, and kill switch integration in case anything went wrong. The code overview, we use Python code for mission control and vision processing and communication. And we had real-time execution on board with the Raspberry Pi. It communicated with the ground vehicle via MavLink, and the UAV sent the Aruka marker and position status to the ground vehicle. They also communicated via telemetry radio and the heartbeat messages to ensure the link health and synchronization. We have a little, we'll go back real quick. That's a little diagram of the first two challenges of what our goal was. And keep it paused on the first frame. So this is the program that we use with the USB webcam to detect the Aruka marker. It sends messages to the air drone. It shows the distance from it, and it'll say where it needs to move. Like you can see, move left and move forward, and you can see in the video when we test it. This video was just a test run, but it was actually attached to the drone. Now we have a power analysis of both vehicles. We have the Arduino, the motor driver, and the gear motors, and the wires for the ground vehicle. And for the air vehicle, we have the flight battery, the 4 motors, the ESCs, the flight controller, and the receivers. Oh, go back real quick. I forgot something. And the Raspberry Pi, it was powered by a portable charger. So, yeah. That's the smallest thing we could use to power the Raspberry Pi.
So what was the flight time?
The flight time,
12 to 15, simulated 12 to 15 minutes.
Right, but that's assuming that it's just accelerating full speed for 12 to 15 minutes straight.
Accomplishments, basically what I did. We developed and redefined our skills on C++ and Python, designed and built the drone, created different software, and basically implemented things that we had already learned throughout our whole engineering course. And a lot of things, like for me personally, I didn't know Python, and it gave me like a better understanding of the activity on my own to actually go over winter semester try to learn it a little bit more. We each did different things to try to like basically benefit our team and make it as best as we could. And we just took it there and we basically took all that and put it into our project.
And this is the engineering stance we put in place for the project. Like you said, we did have to start from scratch learning a bunch of different things, but we did try to implore every little thing we could to make sure it got off the ground and started working, including like Marcus, our mechanic, he used our Duke pilot to make sure that it got the GPS working and it can actually like find home base from where it was. Him, me, and Quay learned Python like during the whole semester, just get it working. And I did use like OpenCV just to get the Ruco marker working and troubleshoot a little bit, just make sure it can get the distance. This is the bill for the materials we use. As you can see, it's kind of lengthy. Towards the end, we used like $790.02. That's like, yeah, that covers everything from the equipment, tools we needed, batteries, microcontrollers, even the drone itself cost like $420. And we really tried to catch every sale we could for this stuff, I promise you. So it's expensive.
That is a thing. Summary, overall, I think our team was pretty successful. Like they mentioned before, we pretty much met every week, multiple times a week to be able to get this done. Because I know for Senior Design 1, we weren't as far as we are now. So it is nice that we were able to get this far. It was unfortunate that we didn't go and actually complete our project because we did work really hard on it. So that was pretty unfortunate, but it is nice to be able to present this to you guys and share what we learned and what we did throughout our 2 courses for Senior Design. So yeah, it was overall, it was fun. And that's it.
Questions, comments?
Which one of you is the project manager?
It's really good.
How did you know?
I'll let him have it.
Do any of you have drone licenses? You know, the FAA drone.
So
It's, and then there's a trust, you can get a trust card too as well.
So Raytheon,
That's
that's what like that's what Bobby and Jemiah had. They had the little, basically the test they took. It gave them a license for like temporarily to fly the drone.
Just for the competition, I mean,
Yeah,
we had to have somebody.
we had at least not to build our sponsor, make sure that we at least had certain things in order.
Yeah.
That was a requirement for the competition. So let me very briefly about the competition. Raytheon sponsors a autonomous vehicle competition. Jackson State was first invited 4 years ago. They're mostly Texas schools, but now they've expanded it. They have a southern region. They have one for just schools in Puerto Rico. They have out west and on the East Coast. And so they all basically have to operate from the same statement of work.
So the same end goal is for everybody, no matter where they are.
Yes.
That's good.
And we were not able to go because of technical difficulties without play. It never took off. So, but thank you for showing up.
And this is what a UAS drone license looks like. It's issued by the FAA, and it's something that it really opens a lot of doors for projects. So anyway, think about it. Part 107 is what it is.
Talk about that.
I mean, y'all said something about an obstacle, what was it?
So for the third challenge, we basically want to do like the second challenge with the Ruco marker, but we had to, it had the obstacle course, which is why we needed the drone that had the vehicle marker and the ground vehicle, which we didn't find it had ultrasonic sensors so it can navigate through there. So the drone will go and find a vehicle marker, and through the telecommunication, we'll send it back to the ground vehicle. The ground vehicle will have to go to the vehicle marker. And that's through the obstacle course, ultrasonic sensors will let it know where to operate from, how to move through there, while they take any rides that they had. Again, we couldn't really go, so we can really test it and see how it was.
In challenge 2 and 3, it was more, we got to challenge 2, we finished challenge 1, we got to challenge 2, started working on challenge 2, but we didn't quite get as far with challenge 3 as we wanted to. And like you said, we didn't make it down there to be able to test any of this out, so just kind of going off the leap of faith. So, yeah.
So what would be the most challenging part about this project? I mean, what's the big obstacle that you face, and how did you work on it as a team?
So for me, from my standpoint, it was honestly getting our big drone to really work. So the main issue that we had at first when we were setting it up was that, again, we didn't have licenses at first. So the GPS, it was saying, oh, you couldn't fly here, you couldn't fly the area. So once we tweaked that, we had to go into, okay, we had to run it. It wouldn't start. We had to program it ourselves, actually. We had to go in there, try to code everything, go through there. And once we did that, we kind of got it up and running. We did a test flight. Our pilot hit it a little too hard, and our GPS came on. So what we did, trying to be our engineers, we went through, tried to do the wiring, tried to solder it up in there, which it did register the GPS, but altogether we had to buy a whole new one and put it on there. So I'd say that was really for me, the most challenging part.
I'd say for me, the most challenging part was probably working through trial and error. So when we would get stuck with things, we would be in Belger's office harassing him every day to try to get it fixed. So that was probably the hardest part for us. And then also putting it all together at the end, because we all worked on different things throughout the project. Some of us did more of the hardware component, some of us did more of the software component. So it was kind of hard to put it all together and make it one thing, but we got it done somehow, some way.
So how did y'all distinguish out, I guess, the work amongst each other?
It's a group of different individuals, and I say different egos, different personalities, but at the same time, we know we still have one common goal, and through communication and effort, we're able to work together, get on the same page, get everything done. But it wasn't really hard work with them. We all, I say, like each other, like around each other, cool with each other. So when we got our bonds to the same thing, we will finish too.
We all have different skill sets, so we just took all of our different skill sets and what we take from our different majors and kind of just put it together to make it one big project. So that's how we were successful.
Thank you.
Good morning.
Good morning.
I mean, well, still morning now. Good morning.
Yeah, still morning.
I'm Reagan Johnson, computer engineering scholar.
My name is Beth Chike, computer engineering major.
My name is Seth Gallo, computer engineering major.
And my name is Peter Goshomi, computer engineering major.
And this is our campus marketplace for our senior design team project. So,
Give us a second.
Hold up. Sorry. I hate to interrupt the flow of your review.
And, see, okay, so, Ms. Laura, that's you? Okay. Reagan, okay, great. And, Seth, all right, and Peter.
Yeah.
All right, great. Good team there. Everybody good?
Good, thank you. Appreciate the time.
so again, this is our senior design project, campus marketplace. It's a student platform that's used to build, that is built and used on campuses to buy, sell, and donate items that are used or unused here on campus. instead of relying on unsafe third-party cluttered apps. Our goal was to help students save money and reduce waste, as well as strengthen our campus community as we are one within the resources that we have. So just to briefly go over our team and the roles that we had. So Seth, right here, Seth is our quality engineer. He conducted a lot of the testing that we had on this project to ensure that everything met the standards that we needed. Beth is our software engineer. His role consisted of the script planning and execution of the project. Peter was our hardware engineer, focusing on developing and creating an affordable solution for our project, and I served as the product engineer owner. And my role consisted of planning and customer satisfaction, as well as collaborative efforts within the team to ensure that everybody had what they needed. So I'm gonna turn it over to Nick.
Okay, so before starting our project, we came up with a script of things we wanted to get done. This was a collaborative effort as a team to know essentially what the problem was, how exactly we wanted to tackle the problem, and the steps we're going to take. That led us to come up with a software component flowchart. Breaking down the project into different phases. As we know, this was a project that spanned across 2 semesters, but we wanted to get it done as soon as possible so we could go to testing with real actual users. So this led on to breaking it down into different phases, as you can see here, just to give you like a quick overview of what it was. Phase 1 to 3 basically had where we called it our foundational phases. It involved the system, the designing of our system, authentication, the databases we're going to use. Phase 4 to 6 went on to implementing our wireframe diagrams, the app's shell itself, connecting our APIs, and ensuring that our data was properly migrated from what we had. So we had 2 different databases. We had what we called staging and prod. Staging was basically for our dev, so where we did local testing, and when everything was done, we migrated over to prod. So to ensure that there is, we're not testing in live databases that the users are actually using in real time. So phase 7 to 9 was where the bulk of the work was done. This was ensuring image uploads worked perfectly. The user could browse for items and had filtering for selections that you'll see later on. Our cart system was working, our user profile was working, and then the donation system, because we also wanted it to be a platform where people could donate items if possible, and then the admin dashboard for ourselves, the admins of the site. And then 13 to 19 was where we all worked together with QA engineer, with like actual testing of what we have, if there were any errors, configurations that we needed to make, and also deployments of our app. So I'll hand it over to Peter.
Yay, my turn. So one of the critical components of our project was to ensure that, or to meet all the requirements of the class, we had to have like a hardware component to our project. However, we decided to roll it out in phases. So in phase 1, we decided to do away with hardware, as it increased a lot of friction to our early adopters in the market. So, but this is essentially how it would work on a very high level, our hardware component. And the hardware component, we wanted to use it as a redundancy verification step to make sure that we don't have fraudulent individuals selling things that actually do not exist on the platform, or advertising things that they actually do not have. So the way it would work is, supposing Beth here uploads his old MacBook that he doesn't need, and I am wanting to get a really cheap laptop, since I'm just starting college, I want to upgrade from my old one. Then I would go into the platform, and then I would communicate with him, as we were showing the demo later on, so that I can get this MacBook. And once we finish the transaction, for the system to be able to know that this transaction actually did happen, that's when this hardware component, where I would bring in my phone and then I'll scan on this component. That component would send that information back to our system. That way the system would know, like, okay, this is a verified transaction that actually did take place from both parties. So on a high level, on your left and my right, yeah. So on the very left here, this is the reader. the hardware component. I think it's in the next picture of the slide, right? This is the actual physical device that the person who's selling would have, and this is my phone that I as a customer would have, and then this is the back-end system that we've deployed. So what we'll do is we decided to use the low energy Bluetooth channel for the application and the device to be able to communicate. That way, once it opens up the gateway channel, the phone application would send device information so that we know who is the customer and who is the seller, so they exchange that information through their secret keys. Once that happens, now the reader, what it would do, it will fetch all the transactions from the phone that the phone is trying to verify. And then because the reader has its own special key that is uniquely identifiable to the merchant, it will sign on all those transactions, say verified, 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 verified. And once all those transactions have been signed, they'll be pushed back on the one application, and then in the background, the application will now send it to the backend over here, which is essentially what all of this is on a very high level. So these are the main components without all the messy wiring that will be in the hardware component that we're going to build. So what we have is a near field card reader at PN532 NFC, and we're going to use an ESP32 and a very small battery. And the reason is because it's some sort of a makeshift POS verification system, and we wanted to make it as small, as compact, that it can somewhat have similar size to a phone, so that it's not bulky for the merchant. So that's why we decided to go with the ESP, which is very tiny. We could like solder it on a PCB board, again with these. So the ESP32 board, what it does essentially is the brain of this hardware component. So it has onboard BLE technology to connect to the app, like I said before, and it can read payloads from the NFC reader. So what happens is the phone will send the payload, beep, and then once it does that, it reads that information, sends it to the brain, and then the brain would have a unique signing key that it would have, and then it will sign on all those transactions that actually did happen. And once that happens, it will also communicate back to the phone via this low channel Bluetooth. And the NFC module, what it honestly does is just to get the payload, send it over there, and then the ESP32 will send it back. And the small battery is just to power everything up. Okay, thank you. Let's go to the next one. And then this is our bill of material and the cost breakdown. Supposing we are only building one, the minimum order quantity is 1. So obviously, as we build more units, the price per unit cost of acquiring each single item would significantly draw down. But for now, the NFC module, to actually build one, we only need 1, but he had put in 2 as this was trying to come up with a budget for this project just in case one fails or anything. And each one fetches a price of $12. And we have ESP32 dev boards, the one with onboard Bluetooth enabled. Each one fetches $10. And then we have 9-volt rechargeable lithium-ion batteries. Each one costs $19. I think in our hardware component, we wanted to put in 3. Each were rated at 3, right? Each were rated at 9 volts and 2100 milliamp hours. But we'll look at that later on. I forgot the exact number. And then we have mini step-down voltage regulators, simply because when the NFC module, the near-field card reader, if it's activated, that it's actively reading something, it has spikes in voltage and current that it draws. So in order to protect everything, we need to have voltage regulators that make sure that it smooths out those spikes. And then we have LM2596 buck boosters. They pretty much do the same thing, but we wanted to have a variety just so that we know like which one really works well for our use case. And then we have connector cables and assorted capacitors to essentially do the same thing to smooth out currents. And then hosting of the site itself, 70. And then we had the total cost. Could you go back a little bit? So the total cost for 1 unit and deploying 1 unit would be 48. And then the cost of deploying the site it's separate with 70. We didn't include it in the 48. So here would be our power analysis for what we want to build. So our 3 main components again is the near field card reader, the ESP32, and the lithium-ion batteries. I know we put 2 entries here, but because we're trying to represent 2 states. So the NFC module, it says that in standby state that it's not actively reading any information. And then there's also when it's actively reading and writing information. Same thing for our ESP32. We put it twice, but it's actually the same thing, but we're trying to represent two states that it's in standby mode, or it's actually doing a Bluetooth transmission. Because those are two states that require different current outputs. So according to the sheets that we have, the voltage, it's pretty much 3.3 right across the board for all of them, except for the lithium ion battery there. And then the current draw for each of those, when the NFC is in standby mode, is 0.1 amps, but the current can peak all the way up to like 0.12 or 0.125 sometimes when it's actually actively reading and writing. And for the ESP32, if it's just sitting in an idle state that it's not doing anything, for our use case, that current can drop down to as low as 0.015 milliamps. And then when it's actively doing something, again, that current can spike up to 0.13. So just based on these numbers, we then calculated power via voltage by current to get these numbers here. And our desired uptime is somewhere close to like 7 to 8 hours, which is just about the same time that a normal cell phone would be up as well. So this is what we wanted, this is what we're trying to aim for. And we're trying to see, okay, if this is the desired uptime that we want is 7 hours in standby mode, that it's actually not doing anything, this is how much capacity to consume in this state, if this is the desired state. And then the desired state for reading and writing, say 2 hours. If you do 2 hours of continuous reading and writing, which we think shouldn't be physically possible, the amount of milliamp hours it draws is this much. We put it here, and then we're trying to balance out with how much capacity the batteries that we have actually have. So that's why the number is here is negative 1300, which sort of cancels out. So we should be able to get about 8 hours or anywhere between 7 to 9 hours of uptime for this device as a rough estimate.
Okay, so I'll speak on the business model. So again, this is marketed towards college campuses, and our key partners will be mainly Jackson State students, but also, like we said, other campuses. Activities would be user support, issue resolution internally, as well as secure student authentications via our student emails. And not to go too in depth into the business model, but this was a good way for us to see how our product could be used amongst other campuses and not just Jackson State University.
Okay, so while we was trying to make sure our project was up to the standard by Professor Besser, we was also trying to make sure it was up to the engineering standards. So we have the standards here, the engineering requirements and the life cycle information, which is the IEEE 29148 and the IEEE 15289. This is basically the planning and the development process. And we go to the software quality and assurance process and the software lifecycle and process, which is the IEEE 730 and the IEEE 12207. Well, this is the testing and the code checking and code implementation. Then we go to the configuration management, which is the IEEE 828. Well, this is where we use the practice of the vision control and the dependency locking. Then we go to the software testing process, which is the IEEE 29119, and this is where we make sure all our practice was up to the standard of the engineering standards. Thank you.
So in this video is a virtual demo of us logging in to create an account for the campus marketplace. So I'm going to let this play. So as you can see, it does require you to use a student email with the I address, the at address students.jhunit.edu. So once logged in, it'll sign you in successfully, and it'll bring you to the home page of the marketplace. So in the marketplace, we have just various items that random students would give away or throw away or sell, and these are some of the items that were placed on here. So we have backpacks, couches, and other things. You can also post an item. So we have a section for title description, prices. It's going a little fast, but on the next slide, we have a QR code that's gonna allow you to create an actionable account and go in and do the same thing that we did in the virtual demo. But this is just a short glimpse of the implementation that we have for the chat, with the rapid response for the marketplace, software. And that's just the overall viewing of the marketplace and the app view. So now for the live demo, you can take out your phones and scan the QR code if you would like.
So purchase some, come on.
And you can create an account. You can create an account,
I think it's unfortunate that for some people they don't have student
Student
emails.
emails, yes.
Because right now we've only gated it so that it's only,
Just a state.
yeah, the domain name has to be @JSU or @students.jsu, meaning that it's a student email or it's someone who's actively on the institution. So if you would try to use like a Gmail account, it would not even allow you to create it, so just say you're not allowed to be blocked. But supposing, even, it works also even for like different campuses. Let's say I was at Alcorn, say @students.alcorn. Whatever, it still allow me to get it, but as long as it's a generic domain like at Yahoo, at Gmail, it would gate you out, because the whole idea of this was to want to create like a hyper-focused marketplace where students can exchange information that's relevant to that specific campus. Supposing you want to buy textbooks, the same material that might be taught at a different institution might have the same that's taught here. And if I know I'm going to take this specific course that SETI has already taken, maybe those notes are already up there. I can just go and purchase them ahead of time.
Right. And another reason why we did this was because, well, for one, for security. Just to quickly explain the implementation of this was like, think of each campus as a bucket, right? And your student email or your EDU email basically gives you access to that bucket. So we don't want someone from Alcorn having access to a GSU campus marketplace because, for one, distance and proximity, you're not going to be able to see each other, and then it's not like we have any shipping features implemented as of yet. So it's for your campus, so you sign in with your campus domain, and you have access to your campus's marketplace. So what someone from Alcorn is going to see, or someone from Belhaven, is going to be different from what someone from GSU is seeing, because you're only allowed to see GSU listed postings, basically. So.
Okay, so at this moment, I'm uploading Peter's MacBook.
It's actually not for sale, just so you know.
Yeah, and that's the item that we're gonna be purchasing. So if you all refresh your screen, you should be able to see his MacBook on there. And would you like to be our buyer?
Sure.
Okay. So you would go.
I'm going to log in.
Oh, okay. Well, has anybody logged in? Okay. So you can go ahead and click on the item and add it to your cart and begin the transaction between you and Peter. So Peter's gonna act like he's you.
Okay.
And
But my outfit is not for sale, just so you know.
and that's how the transaction will go forth. Peter, you can just explain the steps that you're going through.
Then I'm just waiting for him to make the reservation and reach out.
Okay.
Is it the profile not found?
I'm sorry, so.
Sorry?
Profile not found.
For
Profile not found?
Yeah, when I click message to it.
No, it should be like an issue on his phone, not here. This is.
So this requires internet access to set up. You're gonna access the internet to provide a link between the customer and the product.
correct.
What if you don't have internet?
That
If you have
is,
campus Wi-Fi,
that is a shame, but on campus, on almost every building, you have access to Wi-Fi's, and there's, I think, 3 Wi-Fi's that are open to students.
So Wi-Fi, okay.
If you're on campus, you should be able to have access to the internet. But I'm not sure if you didn't pay your bill for your phone and you're off campus.
And shortly we'll see whether or not we have Wi-Fi on campus or not, won't we?
Yeah, plus just shortly after us, there's actually a team that's actively working on fixing a lot of Wi-Fi issues that we have here. It's a pretty exciting project.
Are you renting a server, I guess, to kind of house all the database for this app?
Yes. So it's deployed on Vercel. So Vercel is this platform where they provision a VM for you that's highly secure, and then you can deploy your application on this VM of theirs, but then it's still managed by us.
Okay.
Yes.
So I'm thinking about the security side of it, of the data, right? So all the, user information, items and all of that.
Right,
So I think you should take that.
So for, like he said, in terms of security of the site itself, Vercel handles that security for us. So it's kind of like giving that to a third party, a well-known third party. And then for the data that we're collecting from the users, everything is hashed and encrypted. So although they're stored in tables, we don't even have access to those. So basically, if you sign in, I can never see your password.
Even the admin?
Yeah, I can never see your password. All I could just see is, the only thing I can see on the admin side is either to block a user or see activities that have been reported. So if your account continuously gets flagged by people on the platform that you are just posting items that you currently don't have, I could then restrict you from accessing the platform.
Yeah.
So, yeah, but I don't see your information. Everything is limited to you. So you're the only person that has the rights to upload your items or delete your items or make edits to your items. So
it's essentially a zero trust architecture.
basically.
And I think this idea could evolve actually to something that the IT
Everything has to be
department on campus, right, can handle, right? So you move all that data to their servers, so they are responsible for the security of all the data on the website and users as well.
That is truly the end goal. We thought we don't want just to make another thing that we make and then we put on the shelf and forget about it. We're really hoping that this could, at least we could use this campus as a pilot to actually really push it and see how far it can go. Because right now it's finals week is next week. If you walk around most dorms, there's a lot of things piled up outside, and you think, surely someone else might find these things useful.
Yeah.
You know.
Thank you.
Okay. Yes.
Two things. One, I think this is really good. It shows an ability to have a community help itself. The reselling of things, that's very, very important. I think our futures are gonna depend on stuff like this because you're gonna be able to go get milk or diapers and whatever through some form like this. The question I have is, did you look at the RFID label cost? I think you used 2D barcodes like you've got here, right? But you also had something that was near field, so that also has like a receiver type thing in it, like you pick up off the shelf. If I try to walk out of Walmart and I've got something that they haven't deactivated, it goes off, right? Are you using both of those in this instance? Or are you gonna use like lockers that have the 2D code and then maybe something for the whatever is being sold? What's the thinking there? Sorry if that was too much.
It was a little too much and a bit unexpected, but that's a very good question actually. What we're trying to aim for was, what essentially trying to aim for is, we're thinking, what is the easiest thing that I think customers are already used to doing? I thought a lot of people use Apple Pay these days.
Yes.
You know, where you emulate the card on your device and we're like, okay, so if we wanted to use that in order to reduce friction for the customer, that we don't want them to change their behavior, we just want to be able to redirect their behavior, you know. So we thought we're gonna want to lean more into NFC technology. However, there are actually two sub things within the phase two.
Yeah, I know, I really made this bad for you, so sorry.
No, not at all, no, thank you. So to go through NFC emulation on the device itself, now we have to like write a written permission to like Apple and say, hey, you want to put this here, this is the use case, this is why it's good, and this is why we decided to do it this way. So that's sort of like the later stage, but for the first stage, what we're thinking is we could give you like an ID card of some sort. You know, so we're gonna pilot it out to see like how do people react to this? Are they gonna adopt it? Are they gonna have issues with this? So The subs first stage is using this RFID cards, like those blank white cards, and then we key it before we give it to an individual. And then
hash it.
yes, and then essentially move away from that to like, okay, let's just put that directly on your phone and we use actual NFC.
Thank you. I know what I asked was a lot. I got excited when you said hashing and zero trust architecture. Those things are really important. As we move on to the future and get into quantum, you're gonna have to have things that are proofed against that kind of attack. And so that will help you a lot. It future-proofs you from the beginning, so good on you.
Thank you. Anyone questions?
Questions or comments?
Hopefully easier ones.
No easy questions for this guy.
She did so well.
Okay. Thank you.
All right, thank you.
Good morning, everyone. My name is Quintasia Gordon.
My name is Cameron Lynch.
My name is Trayana Williams.
And this is?
They'll get just like
Oh,
you.
I'm sorry.
Good.
I'm good.
Okay.
Thank you.
Hold on one second.
Yeah, hold on. We're slow riders.
Yeah.
And, so 2 C's and 1 E there, okay? Thank you.
All right, so let's start with our problem. So, like me, I know it's been many times we've been driving and you've been maybe running late and you go through a parking lot and you can't find any spaces. So we know that parking congestion causes a lot of time waste looking for spots. So we also know that many current systems are very expensive and hard to maintain. So our project is to create a low cost, reliable, and cost efficient solution to help with parking tracking. So we present to you the smart parking system. So our smart parking system uses 2 pneumatic road tubes connected to 2 pressure sensors. These are set up at the entrance and the exits of 2 parking lots. So when the car drives over the 2 tubes, it detects whether a car has entered or a car has exited. These tubes are also connected to 2 ESP32s that are emitting data to an LCD screen that shows the amount of available parking spots in a parking lot.
That's essentially the way they do roads, you know, like to detect traffic, you know, so thing goes across the road and
Like a little
it
black
counts the traffic.
Yeah, that's actually exactly what we did, just on a
Smaller scale.
smaller system,
Yeah.
So this is basically our bill of materials. We already had a lot of materials from our previous classes, but we already listed them on there as well. So we have 2 ESP32s, the LCD screen, and the 5 volts battery, which were materials that we already had. And then we had to get like a rubber stopper for the end of the pneumatic road tubes, as well as the pressure sensors, and the barb clamps that were connecting the pressure sensors to the road tubes that were things that we came out of pocket on. So this is basically a system overview, a more visual system overview. So like Quinn said, we will have the entrance pneumatic road tube as well as the exit pneumatic road tube that is also connected to the end of the entrance pneumatic pressure sensor, or the NPX pressure sensor. So once the entrance road tube is triggered that, hey, a car has gone over the entrance, that would send a delta -1 to our ESP32 showing that, okay, that's -1 available parking spot in this garage. And then once that car leaves that parking garage or parking lot, then it would show a delta +1 showing that, hey, that's +1 available spot in that parking lot. And then this information would be transmitted onto our LCD screen.
Alright, so right here is our software flow chart. So when a vehicle crosses a tube, the pressure spikes is converted into an analog voltage signal and detected by a respective ESP32. So the entrance node sends an event value to the exit node, which stores and updates the count. So also I did create a code which will measure the MAC address, which is a unique ID which helps both our ESP32s communicate with each other, so it can ensure the parking spot, so it can ensure the parking count updates correct.
So right here is our schematic. So this is our entrance ESP32 and our exit. So we use two 10K resistors, two capacitors. So this is our exit sensor right here, which would connect to our display. And this is our entrance sensor right here.
So this is basically our power analysis. Currently we have that with the 5-volt battery that we're powering it with, we would be able to run this system for 3 days, approximately 3 days. We are thinking that on a bigger scale, when we were to scale this to a point where it would run for weeks and weeks of maintenance, eventually we would have a like solar panel or solar charging to where we would be able to run this off of the sun. Instead of having to constantly maintain this and change batteries weekly or monthly. So that's what we are thinking, like on a larger scale, but on this scale, this system would be able to run for 3 days. So every 3 days, we would have to have a maintenance guy go and change the batteries in this parking thing, which is not ideal, but for the scale of the project, that's what we would have to do.
Have you considered a solar, you know, like I have a greenhouse and I have solar panel and it's a low usage, but that way you don't have to connect anything.
Yeah, so that's what we wanted to do on
Okay.
a larger scale, but when we were looking at all of the like solar panels and even on a smaller scale for this project, it was still like kind of out of our budget, so we're just gonna go with the battery, but that's the goal. That's the goal, that way it doesn't have to be maintained as much.
Alright, so we're now showing our Gantt chart. So for the fall semester, we pretty much stayed on track. It was a bit easier to stay on track because we didn't really have the actual components. And then for the spring semester, we stayed on track, but we did have a couple of issues with reordering some parts and getting new tubes and sensors. But for the most part, we pretty much stayed on track.
So like you said, for future implementations, we would on a bigger scale have a solar system where that is what would power this parking system. We also, I guess in our head, I guess the question would be, what makes this different than just a regular parking garage or just a regular, okay, well, we have parking garages in downtown Jackson. Why can't we just build one of those on Jackson State campus? Well, the way that we wanted to scale this in for students would put it on our JSU Go dashboard or put it on something that we use on a day-to-day basis as students, to where when you put in your directions from your apartment or from your house to campus, you can already pull up which parking lot or which parking garage that you're gonna go to on your way to campus, so that you can see, okay, well, I already know that the John A. Peoples lot is full, so I'm not gonna even go in that side of campus. It takes, you don't even think about it, but it takes 5 minutes to get from this engineering building side of campus to over to the student center around both of the roundabouts. So that's just wasted time when you could have already kind of planned your route on your way to the campus. So that was just kind of how we would want to implement this on a future basis, because I don't necessarily know where you could like plan your route on certain parking garages here in Jackson.
All right, and so this is basically kind of a mess with the slide we're going to show after this of our demo, but this is just a snippet of our code. So for our pressure sensor, we set it to have a weight threshold of 2,600. So that way it wouldn't spike if like someone just walked over or someone rode their bike over. So it would have to be like a car size thing for it to even spike. So go to the next one. Okay, before we start the video, just to kind of explain so you won't be confused on what you're seeing. Oh, okay. So for the sake of the demo, let's just assume that we're going into a very small parking lot with just one spot, right? So before you cross over the threshold, you enter, it says 1-1. You go in, once you cross over the threshold, that number goes from 1 to 0, so it shows 0. Now we're showing the exit. Before the car crosses the threshold, it's still gonna say 0 because you haven't, it's still gonna say 0 because you haven't crossed over it yet. And once you cross over, that number's gonna go back to 1, showing that there is one spot available in the parking lot. So maybe start back over.
It's a little blurry when I put it on here, but it's...
And we can pause it if you need to just see exactly. So we use the Honda, so, oh, it's real blurry.
Yeah, you can't even see the numbers.
We could bring it to y'all if
If
y'all,
y'all would
want
like to see
it.
more
Yeah.
in depth, but yeah, it's showing the numbers on that.
It's showing the
Yeah.
one and but we can bring it up there real quick if y'all need to see it. Right now or after.
We could just, we'll walk around with it after, but it's up there. Okay, and that was just Quinn just going in the parking lot and then coming out of the parking lot, showing the proof of concept that this is something that actually works.
Yeah.
So in conclusion, our smart parking system provides a simple, low cost, and reliable way to manage parking availability in real time. Like I said, we use the pneumatic road tubes, we use the NPX sensor, and it's actually communicating through wire communication because there is a node in the middle of the parking lot where that separates the entrance and the exit. So our entire system will be sitting in the middle with the tube going on the entrance and the tube going on the exit. And yeah, overall, this project just shows how practical engineering solutions can make everyday campus experiences easier and more efficient.
So, would y'all like us to go ahead and show y'all the video real quick? For further questions, so y'all can just get everything. Okay. So, you gonna show them the video? The video? Or I can show it on my iPad.
This video?
Yeah, I thought I was gonna take it to them. They can see it.
Well, I thought you said after.
That's okay.
Oh, okay. Okay. Well, yeah, never
We'll take
mind.
your word for it. Questions, comments, before I get started?
So if you have a multiple-story building, right, parking, so is there a way to scale this to show how many available, parking spots on first floor, second floor, third floor?
Yeah, I think ideally it would really be based on how the parking lot is designed. So with a multi-level parking deck, if there is an entrance, like an entrance going on every floor, then we could have a separate sensor for each floor. But they don't have that, it kind of would be more difficult to
It would still
track.
be it's still one entrance to get in the 3 stories.
Yes.
So once you are into that 3-story, 5-story, 6-story parking garage, we would still just keep that in the count of, okay, it's 500 or it's 600. I can say that it could get more specific to where we have these on each floor that shows, okay, well, now that you're on the 3rd story, there's 100 on this 3rd story and there's 56 open. So that could be more specific for each story of the parking garage.
Do you have any idea how often you have to change the pressure sensor? I guess, does it weird or like?
You said how what?
How often? I mean, a couple of years to change that sensor.
Well,
Or is it pretty durable and stays there?
I'm not gonna lie, this pressure sensor, the one that we have for the project itself, might not be the most durable, just because it was something that was, for us, cost efficient for the project. Now, there are pressure sensors that are more durable, but they just, cost just a bit more. But this one, maybe not as long.
So here's a question I'll ask again that I asked several weeks ago. You should have had time to think about it. It's just telling me that one car left or one car came in, but it doesn't tell me how many cars are in the parking lot. How do you start?
So what I was saying the idea for the demo was the total number of parking spots for that one was just 1. That's how we set it for the demo. So if the parking, that's how many is in there. It's just 1 for that demo. That makes sense?
But
So we set it to like 23. Then it would say 23 before we even entered the parking lot. And then it would say 22. And then once you leave, it would say 23 again.
So I think what Quinn is trying to say, can you ask the question again?
Sure. How do you initialize the system? So I have cars in the parking lot already,
Okay,
and I put this system in place.
okay.
How does it know how many cars are already there before any cars come and leave?
That's something that you would have to log into the system. I mean, we would just have to count. Okay, we started with 15 cars in the parking lot, so we would let the system know that
It's already
15 out of 100 of these slots are already occupied. And then once those cars leave that lot, then that would show 14, 13, and then one comes in. Now we're back at 15. So that's just something that we would have to put in the initial startup of this program. That's how many cars were in the lot when we installed this system.
Okay.
But the parking lot that we tested this on had no cars in it. so we started at 0. But I feel like that made more sense. I mean, we could change it and we could put 15 like that. That was just another subject line on our LCD screen, but it's still, either way, the system would still run the same.
Okay, but the point was, when you have a system, you have to initialize it with something. And you can't just assume that there's nothing there, because you may have a parking lot that has 0 cars there because it had never been utilized. They just built it, now they're putting the infrastructure in place, and now you can start letting cars come in and say, oh, okay, we have 500 parking places. There are no cars that have ever come in, so we know there are 500 parking places available. Car comes in, okay, there's only 499 left. The point I'm making is your system, your software should have some means of initializing what the value of the number in the parking lot is, regardless of whether it's 0 and there are 500 parking places, or it's 500 parking places and 480 of them are filled.
I think it might
You
be
need to go back to your software and look at how when you initialize your system, it needs to start somewhere.
Yeah, it does, and we started it at 0. But we can start it, like, we also tested it in the parking lot that's across from the, one university.
It's just
like,
getting painted, so we couldn't do it for the video.
Yeah, so we tested it in both parking lots, and like that one had 5 cars in it. So when Quinn's car came in, that made 6, and when Quinn's car came back out, they made 5, and then when Cam's car came out, that made 4. So like, we put it at 0 on purpose to show that, like, on a blank canvas, but it was no problem for it. Like, that's still a line in our code where you can initialize that it's already 5.
Yes, and
cars.
just to make sure we understand what you're saying. So when we first demoed our project, let's just say the lot that we couldn't use because it's getting painted had 25 spots. So we initialized that it had 25 spots, and if it already had 3 cars in there, we would put 22. But that's the idea. Like, we understand that it has to have a starting point, but just for the demo, that's just kind of how we did it. If that makes sense. If that's touch bases.
It makes sense. What I'm challenging you is to think, if I was actually going to do this, I would have to have this as part of the system in the beginning, not just for the demo.
Yeah.
Okay.
Understood.
Questions? Comments?
Did you do an ecosystem review, as in other products out there like this, or that do smart parking?
Yes, we did do research on other like smart parking systems, but most of them that we came across were just like parking garages, or like if you stayed in an apartment, some people's apartments will let you know like if the parking lot is full. But this was something that we scaled down, and they're actually a lot more expensive, like thousands, 10, 15, 20 thousands of dollars. And they also come with the building of the parking garages itself. And they also have cameras that are viewing the cars coming in. So yeah, this was just on a lot smaller basis, but essentially the same concept.
And what app you say y'all were using? Are y'all was tying it back?
Oh yeah, we would tie it onto our campus. It's a app that we use campus-wide called JSU Go. We like check our grades on there. We check our classes on there. It's just like a hub type of thing. And you also can put there's a maps portion on there that can show you like directions to different places and buildings on campus. So that would be a way for us to add those parking lots on that maps, so that when you're driving to campus, you can see which parking lot you're going to and how many spaces are available in that parking lot.
I was gonna say, you guys should probably sell this to Waze.
Oh yeah, probably.
Because I would totally like tag myself and say, you know, by the way, this parking lot has 5 potholes in it.
Yeah. Right.
Something, you know.
Yeah, definitely. Waze will tell you everything you need to know about where you're going.
Yeah, I like it.
Have y'all thought about how we would handle something entering the parking lot with more than 2 axles?
More than 2
axles, like 18 wheeler.
That is something, because we had a threshold, and I think we had a limit as well, so it had to be a certain point and a certain cutoff, just for our pressure things to work, like for the spikes to even happen.
The simple solution is no 18 wheelers allowed.
Yeah.
Right. Which is, that
Must be
happens a
under this
lot in
height
a
to
lot
ride
of
this
parking
ride.
garages and parking
And
lots.
then like for the spaces that we're planning to put these in, are 18-wheelers even allowed to come in those? Like,
Yeah, no.
No,
Yeah, no.
they're too tall.
Yeah.
They almost always have one of those
Yeah.
bars that says anything over 9 feet or something
Yeah.
like that can't come in, usually.
But it shouldn't make a big difference, right? Because you're just measuring the fraction of how many axles the vehicle
Yeah,
has, right?
yeah.
And assuming that an 18-wheeler is actually would weigh more than a regular vehicle, it would just pass the threshold value that you set, right?
Yeah.
So yeah, I think
It shouldn't be
make
an
a
issue,
big
yeah.
difference.
Yeah.
Just that maybe it's an 18-wheeler, it might take more than one spot.
Yeah.
Well, I would challenge that with this. If you're counting how many times this thing gets activated, one by the front axle or one by the back axle, and you're not looking at how long it took to get that second pulse,
That's what I was gonna say. It would have to be a time, like
Yeah.
some type of clock that would be counting, like how fast the second axle of the 18-wheeler
Yes.
went over the pressure sensor.
then you would know it's an 18-wheeler, or it's an 18-wheeler going 50 miles an hour as opposed to a Honda.
Another solution would be to embed a metal detector instead of using a pressure sensor, a metal detector into one of those plastic speed bumps, and regardless of how many axles, it would just read
It's still gonna-
one
yeah.
body of metal coming into the parking lot, and it also would have no moving parts and wouldn't wear out as fast.
So I hope nobody with a unicycle comes in the parking garage. We don't know if we can read that.
Any other questions?
I'll ask the last question, I guess, about roles and responsibilities. Who did what?
okay, so let me start. Okay, so I mean,
We all did everything.
yeah, I'm not gonna lie. Okay, so I guess you could say I was the project manager. I kind of like I ordered the parts, I sent the parts back, and I made the Gantt chart. But I also helped with like building the actual like the system itself.
I would
and
say, yeah.
troubleshooting.
Yeah, I would say Cam is our software engineer. I was our hardware engineer, like the basis of it. I'm the one who like did the research on what products we needed, what parts we needed, what parts we had. And then Quinn was really good like at keeping us all together and just kind of like floating between me and Cam.
Okay, great, thank you.
Did you bring him coffee?
I can fish. What you want? Cream? You want a black?
Thank you.
How y'all doing? My name is Jonas Goss, electrical engineer.
My name is Tyler McLaurin, electrical engineer.
My name is Lamont Sims, computer engineer.
Let me get y'all a second to write that down.
Basically, right to left.
Tyler. Thank you.
Almost.
It'll be better if it's not me.
No, I just wanted to get you on camera here. You should be okay there.
Everybody ready? So this is our project. So basically our objective is to make Wi-Fi visual and give a real-time update or status of the Wi-Fi across campus for students. So we have online students here at Jackson State, but we also have commuter students. So if you're coming to Jackson State, let's say you stay off campus. If you're driving up to campus and you have a test to take, where's the best building to go? Because I know for like Canvas or the test we take, once you start it, if your Wi-Fi drops out, that's kind of tough. You don't get where what you make. So we wanted to come up with a solution to that problem by labeling the Wi-Fi signal by building to give students a better idea of where the Wi-Fi signal is best on campus. So the approach that we started off with, so we are using ESPs to scan the Wi-Fi continuously, and so we upload that to a flash server. And so we started here with Carto. So what Carto is, it's a tool used by a lot of civil engineering majors. So it's a geo mapping app, but it costs a lot of money. So we were on the free trial 2 weeks, We have to make a new upload every 2 weeks, so that got to be a lot. So what we did, or where we are now, is so we use Carto, but we switched over to a JavaScript library with the geo-mapping feature to build our real-time campus hot map based on Wi-Fi signal.
Okay, this is our Gantt chart. This is our timeline that it took, starting with the first semester. We did project planning and research. Then we moved on to hardware procurement and setup. And then we started programming the ESP32s. And then we got to server and database development with, we didn't use Carto integration anymore because when we went to develop the web dashboard, that kind of wasn't working out. And then we went to campus deployment and testing and optimizing and data analysis. Then now we're at the final reporting.
Cool. So this is where we started. So this is our early heat map imaging. This is with Carto. So you see right here like I guess it's 2D, or I don't know if it's 3D. I guess it's 3D. But you see an image of our campus. So this right here is the plaza. This is where we are in the engineering building. And so we were assigning a signal based off of the latitude and longitude of the buildings. So we had to input those coordinates to say this building is here and place an ESP in the building and then attach a color code to it. So this is like very rough draft, So this is where we started and this is where we are today. So you can talk more about it.
Okay, so basically we implemented another mapping system into our web server that allows us to store the data more easily. Because Carto, it wasn't working. Well, it was working, but like it was harder to access. So this was more easier for us to use, and we was able to put the coordinates and store the data easily and get it to upload colors.
What about obstructions and multipath? Both of those could cause loss of signal, but like in downtowns, you don't get a good signal. And of course, you're doing outdoor only, not indoor, right? Conferences really focus on this, trying to supply Wi-Fi for the whole building, a large auditorium. But what's the goal here about Wi-Fi? What's your objective? Delivering Wi-Fi for 98, 92%, or 98, or 75? What's your goal?
So our goal basically is to give students a live view of where the Wi-Fi is best on campus. So let's say we're in the engineering building. So if it's a lot of us, and this is a screenshot, we're gonna go to a live view after we finish the slides. But so this right here is our student center on campus.
Is this for Wi-Fi coverage? Is that what I'm getting at?
So it's for signal strength.
Signal strength.
Yeah.
There's a lot of interesting things. Transmitters, if you're testing a cell phone to a base station, you get power, and depends on if it's CDMA or what technology. But then with receiving, you have to worry about fading, as you drive along. So you're just tracking static targets.
Yes, sir. So we just scanning from one physical location, or we got the ESP right there. So it's scanning the Wi-Fi in this room, but giving a representation of the building. So you're seeing a live signal strength at the time.
Like a heat map.
Yeah.
Yes.
Yeah.
Would they be strictly Wi-Fi strengths, or is there like internet on the Wi-Fi too? Because Wi-Fi could be strong, but you don't have gateway to the internet. Would this be able to tell you if it has access to internet?
Well, Lamont, you can answer that, because it's scanning the Wi-Fi, but also you have to be connected to the internet for it to.
The ESP32 is connected to the Wi-Fi as well. So it's on the Wi-Fi, and scanning the Wi-Fi and sending back the screen of the Wi-Fi.
So it's attached to the routers?
So it basically couldn't transmit data if the Wi-Fi wasn't working, if the internet wasn't working, like to the.
Oh, okay, so you're using internet-based basically.
Yeah. And yeah, so this is like heat map with the color coded signals, but now we're gonna get more into how we determine the signal.
This is our Wi-Fi grading, and it corresponds with the colors that's on our email. So like from -30 to -70, excellent, and then good, fair, then weak, and so on.
And basically, decibel milliwatts is how you show receive. What's it? I think it's receive signal strength indicator. And like he said, the ranges is how we came up with the color codes.
Are these colors backwards or it's just? I thought red means like it's really good.
No.
Go ahead.
So how did you come up with the ranges?
So. So we will, when we show the live view, it has the ranges that we have, but we basically just looked up what's a good RSSI or a good decibel range for Wi-Fi.
Yeah, what did you use to look it up?
Oh, Google. Yes, man.
I wondered if you used some of the standards that give you, hey, you can get this kind of modulation and coding out of this particular signal level. And signal to noise, because that's what really gives you how good this Wi-Fi is. It's not just how strong it is, but how much interference is going into it. Did you look at signal to noise or just signal strength?
We really mostly just signal strength. Yes, ma'am.
This is our software flow diagram. So basically we have three ESP32s connected to the Wi-Fi. They will scan, they'll send that to a flash server, and they'll store the Wi-Fi, the RSSI, and then the JavaScript will pull the stored data, and then they'll upload it onto the web mount or heat mount.
Cool. And we started with three ESPs because we wanted to take the engineering building, because we knew we'll be here, the student center, because that's like a very popular or heavily populated building on campus, and also the library, because a lot of work gets done in there. So that's how we came up with the 3 buildings we wanted to use for our test kits.
Let me ask this. So in that diagram there, where you have the pins, is that good Wi-Fi or bad Wi-Fi?
Oh, this is just like an example. Like, so we're gonna get to ours, but it's just an example.
And so that ESP will be placed in one location, right? What about the other extremities of the building?
Talking
I'm
about
on
putting
the
a
far
device
end
per
of the
location.
engineering building, or this far end. I mean, how do I know if Wi-Fi is good?
Well, that's good.
Would
I
be
guess.
more ESPs.
I guess we would need more.
Yeah, more in the building to get a more accurate picture. But the idea we had was to place it in the lobby of these buildings. So like when you walk in, this is a real time picture of what you'll see, or what you'll get in the common areas.
So this is our power analysis. It just shows how much power the ESP uses at all stages. But I mean, we really wasn't focusing on efficiency because it would be plugged into the wall all the time. So, but we still did a power analysis. Okay, this is the bill of materials. So the ESP32, they were $10 a piece, and we bought 3 of them. And then 505 power supply, well, we bought 3 of those at $10 a piece. And a USB-C cable to upload our code to the ESP32, and it was $10. So total cost was $70.
And this is our business model canvas, so how we could scale this up. So we took Jackson State because it's like our home or our example on campus, but this is also a thing that could be implemented with multiple universities or any large scale site with different buildings. And you say, okay, hey, I want to be able to see the Wi-Fi strength down the plaza, so to speak, or a few buildings down the line. So that's a few of our key partners, or how we can scale it up. Revenue streams, we could get licensing agreements or have subscription-based monitoring services. But ideally, it's a pretty good small model concept, but it could be sold or scaled up depending on the location you have. Okay, go to the library. So this is giving you a picture of the Wi-Fi in the engineering building, the library, and the student center at the moment. So right now we're getting a good Wi-Fi or good signal in the engineering building where we currently are. But in the student center and the library, it's spare signal strength, but it's really not doing that well. And one more thing we want to show is the signal strength. So you just have your ranges down there as well on what you can expect. And you have a 2D map of the entire campus. So the idea is to get a label for every building, but we just started with a few of the most populated buildings. Oh, my bad. Oops. But I'm missing that though. But any questions?
How many locations within the building did you use to say how good the Wi-Fi is?
We use the lobby because yeah.
Just one at the moment.
Just one at the moment.
What's the refresh, I guess?
I think it's refreshing every 5 seconds. Yeah.
Okay.
So it's a continuous scan as long as you got power.
Any more questions or comments?
Always, I'm the talker. So, I think there's added integrations, like you guys are starting, so this is just like proof of concept and making sure that it's working. But there's other things that you can do. Wi-Fi is generally password protected. So different Wi-Fis might have different privileges, so you might have something that's specific to faculty or specific to some kind of government work, like you have to do everything within this particular bubble and have all those authentications. So this is a good start, but I think you guys are gonna find that you're gonna end up putting a lot of other things into it.
You tell about EDU-ROM. Like, so we scanning the student Wi-Fi right now. So EDU-ROM, so you have to have a J number in your JSU password. So we really scanning the Wi-Fi that's primarily used by students.
Yeah, and I do agree that as a service, if you will, is a good thing. When we went through major problems during COVID, one of the things that C-Spire did was we added Wi-Fi boosters to the parking lot of stores so that students could drive to the store and go to school. So what you're doing, I mean, we've proven out that that's a good thing to do. So it's a really great concept.
Does this actually allow you to see the speed of the Wi-Fi, right? So I'm thinking two concepts, so like the strings and then how many devices are connected to that Wi-Fi at some point.
Yeah.
Right? Like if you
Saturation, right?
Exactly, yeah.
Well, I guess in my mind, and you tell me if this makes sense, but I thought the way it works to me is if we had, let's say, added 100 people to this building, it would be a worse signal strength. Would you say? Or
No, the signal strength will stay the same. It's the signal to noise that will change, and that's what gives you how how good your Wi-Fi performs.
Okay. So the strengths and the speed basically are two separate things, right?
Correct.
Yes, you could have a good Wi-Fi connection, but at slow speed because there is too much traffic.
Yeah.
And it'll give you a data point to prove it needs to be improved. You're gonna be able to go, no, really, we do need better Wi-Fi, see? So, it's a good thing.
Yes,
Okay, all right. Thank you.